we're going to continue our journey on learning about the 5 types of chemical reactions. By the way, if you're wondering why I have this little asterisk up here, these are the 5 main types of chemical reactions. There are actually others, but many fall into these 5 categories. In the last lesson, we learned about synthesis and decomposition. We learned that, which one of those two, synthesis or decomposition, is when one compound breaks apart. That's decomposition, right? Synthesis is when things come together. So in today's lesson, what we're going to learn about is we're going to start going down the path of learning about single displacement and double displacement reactions. As a matter of fact, this lesson is completely about double displacement reactions because once you get the handle of double displacements, the single displacements go relatively easily. So what do those two terms mean, single and double displacement? Well, the first thing you should know is depending on where you're looking on the internet or even on tests, sometimes you'll see them say, is this a double displacement reaction or is it a double replacement reaction? And we're kind of wondering, does that mean the same thing? And sort of it does, right? If you watch what's going on here, then this sort of general representation is you can see this yellow atom, right, is bonded to this green atom. And what it does is it gets rid of the green atom and picks up the blue one. You see on this side? So it's almost like the yellow one and the red one swap their partners. They replace their partners. Their partners displace each other. It is sort of just, it's kind of like if you've ever done square dancing, right? You know, you got a do-si-do, you swap your partners and off you go. It's kind of like that. That's double displacement. So what the word displacement means is to take the place of something. Right? So it's sort of like getting bumped out. You know, you could imagine that the green one came over and bumped out the blue one, right? That would be displacement. Obviously, replacement means to take the place of something. So that's as if the blue one left and the green one said, oh, I'll take your place. Replacement is more polite. But the point is they swap. Right? So you can see down here, if I kind of use my sort of ball model of the atom switching and look at an actual reaction, you can see that the nitrogen, the green nitrogen here, is going to take the place of the chlorine, and the chlorine is going to take the place of the nitrogen. Pretty simple, right? Now, let's look at how you actually do this, how you predict the products of them. So I've color-coded these in a very important way, and it's the way that you mentally should start thinking about them. Because it turns out that not every partner can go with every other partner. Like you might be sitting here thinking, is it possible for the nitrogen and chlorine to get together on the other side? What do you think? And the answer turns out to be no, but why do you think the nitrogen and the chlorine can't get together on the other side? Yeah, they're both negative, right? The positive ions are on the left. Calcium's +2, nitrogen's -1, H is +1, and chlorine's -1. The positive ions are on the left. I've color-coded them orange, and the negative ions are on the right. You'll never see the two negative ions, the two blue ions get together. You'll never see the two orange ions get together either. They have to have a positive and a negative get together. So tip number 1, make sure a positive ion gets together with a negative ion. Now, I didn't write this down, but you know that when you get a positive ion together with a negative ion, it might be backwards on camera, but the point being is it the positive ion or the negative ion that has to be on the left of the formula? Definitely the positive ion has to be on the left of the formula. So how do we predict products here? Well, we need to be careful about what gets swapped. So generally what I do is I write the positive ions first. So I'm going to write the calcium and the hydrogen on the other side. I'm going to space them out by a plus sign and give myself quite a bit of room. But I write those two first. The reason I do that is I set them up to accept a partner. And now I know I won't accidentally get the calcium and the hydrogen together because they're both positive and we can't do that. So write the positive ions first. Now we're just going to take the blue ones and swap them. Calcium was originally with nitrogen. We're going to get rid of that. And I think I need my pen here because I don't think I actually have anything that's going to appear. But calcium's going to get rid of nitrogen and it's going to pick up chlorine. So I'm going to write a chlorine there. And then H is going to get rid of chlorine and it's going to pick up nitrogen. So all they're doing is swapping their negative partners. So write down the positive partners first. And then notice what else I did here. And I think this doesn't surprise you from our work in synthesis and decomposition. But don't write down the subscripts. Do you see how I did not bring the 3? I did not bring the 2. I'm not bringing them. And the reason is because you know over here with these two compounds, because of their compounds, are we going to check for diatomics or are we going to check charges? charges. We're going to check charges, right? Because there are no elements by themselves here, so we're going to check charges. Remember how I told you way back at the beginning that if you just, every single time you see an element by itself, you check for diatomics, and every single time you see a compound, you check charges, it's going to carry you through everything we do? It is. It's true here as well. Okay. So yeah, the reason that the 3 and the 2 were here was because when we check charges between calcium and nitrogen, that's just how those charges turned out. But let's try it for these two. Now for these two, you are going to need a periodic table, and I bet I'm going to have it linked in a second. But what I want you to do is check the charges of these two and type in the formula for that we'll have. Did you get CaCl2? Yep. Why? Because this is +2, that's -2, that's -1, and therefore you're going to need 2 chlorines. So you have a little 2 down there. Remember, at the end we're going to erase those charges. And then what's the formula for this one when you check charges? Well, this is +1, that's -3, so yep, H3N. It's going to take 3 H's in order to do that. That was why in that last unit we worked so hard on learning to write formulas, because we're going to need it throughout everything that we're doing here. And if it's something you're struggling with, then you definitely need to reach out to me and I will help you with it. All right, there we go. We've checked charges on both of those compounds. We're done. We did a good double displacement reaction or double replacement reaction. Now, I haven't balanced the equation. Let's just do it real quick. I'm going to put a 2 here. Why? Because there were 2 chlorines on this side. Now I have 2 H. Oh, no, this is a hard one. See, I have 2 H's here, but I have 3 there. Maybe I'm going to put a 2 here. 3 there. Oh, this is going badly. let me work this out. Did I check? You know, by the way, if things don't balance right, usually it's because I have one of the charges right. Let's see. You know what? Actually, I'm going to do nitrogens first. You know, just because it's not working out. So if I have the nitrogens first, let me erase my ink. I'm just going to continue this because I want you to know that if you ever get stuck balancing, if you see this obviously, then at the moment, then you're doing great. If you don't, then sometimes erase and start with a different element. Nitrogen is, there's 2 of them there. So if I put a 2 there, that gives me 6 hydrogens. I have 3 calciums, which means clearly I'm going to need a 3 there. And I've 6 chlorines, so I'm going to need a 6 there. 6 chlorines, 6 H's, 6 H's. I think we're balanced, right? Yeah, I think we're balanced. So I kind of got stuck going one way. Erase it all, start with a different element. Anyway, so as we go through this, we're probably not going to balance every equation at the end because I don't want it to drag out too much. But yes, that would be the last step that you would do with every single one of these. Okay, let's try this one. Now you see that I still have the color coding on here. The important thing is don't put the orange ones together, right? Don't put the blue ones together because those are the same charge. So you know step 1 is to write the positive ions down. Which are the 2 positive ions that I write first? Magnesium and aluminum. Very good. Step 2 is to swap their negative ions. And so that means magnesium is going to get, ooh, I'm going to get my blue marker back. That means magnesium is going to get which partner right here? Oxygen, that's right, because it had bromine, it got rid of bromine. And aluminum is going to get bromine. Now, at the end, we just need to check charges. I want you to check charges and tell me what the formula is for MgO. It is what it is, right? Because this is +2, this is -2, and we didn't need more of either one of them. What's the formula for aluminum bromide? This is +3, that's -1. We're clearly going to need 3 bromines. And so I go like that, and then at the end I come back in and do the proper thing all chemists do, which is erase the charges because it's a neutral compound in the end. By the way, you might wonder, why do I erase charges? It's because there are times when you have charged species that really are charged, and we don't want to confuse the meaning of charged ones and uncharged ones. Anyway, doesn't matter too much. And then at the end we would balance the equation. If you want to pause the video here and balance the equation, you absolutely can do that. Okay? All right, pretty good. Now you notice I've removed my color coding here. So that means you need to know what the positive and the negative ions are. All right, I write down the positive ions first. Which 2 ions should I write down first? Oops. That's right. Apparently I didn't. Let me do it all in white since we're not color coding anymore here. That's right. I write down lithium because it's a positive ion. It's always the ones in the front that are positive, right? And strontium. Spread them out good because you're going to swap their partners. Now, lithium used to be bonded with sulfur. Now it's going to be bonded with fluorine. And I'm not bringing any subscripts. That little 2, I'm not bringing it because I'm going to check charges over here. And SR is going to be bonded with Sulfur, that's true. Notice I'm not bringing any subscripts. We're leaving it as is. Now, when you check charges on lithium fluoride, check charges and tell me what the formula is. Yep, +1, -1. It doesn't need anything else. And what's the formula for this one? +2, -2. It's already neutral, right? We don't have to worry about it. All right, let's do the good chemist thing and erase our charges at the end. And then if we wanted to at the end, now that we've already checked charges, we could balance the whole equation. Oh shoot, why not? There's 2 lithiums, 2 fluorines. I've got 2 fluorines, 1 strontium, 1 strontium. I think we're good to go. I think it's balanced. And yeah, you don't have to put ones in front of it unless you're doing it on a computer, right? All right, very good. Now let's try this last one here. So how do we predict the products of this one? Well, we start with writing down the positive ions first. Which 2 ions should I write down first? Boron and calcium. Very good. And then boron is going to be bonded with what atom? Oxide. That's true because it had fluoride on it, but it doesn't anymore. And calcium is going to be bonded with fluoride. Very good. I want you to check their charges. What should I write down for the formula for barium oxide? Well, this is +3. That's -2. And so I'm going to need 2 of these, and I'm going to need 3 of those. And then what's the formula for calcium fluoride? CaF2. That's exactly right, because this was +2, that's -1. We clearly needed 2 of those, and we are done after we erase these charges. And I'm not going to balance this one, but if you want to pause the video, you certainly can do that. That always would be our last step in this process. Okay, so we've learned how to predict the products of double displacement reactions. Now, in the next lesson, we're still going to be working on double displacement reactions, and the reason is because we're going to be looking at those problems where polyatomic ions are involved. It's not really any different. It's just there's a subtle trick to it, which we'll see in the next video.